What's up, Prealgebra students? This is Lesson 31. Our objective is how do you add integers and combine like terms. I'm going to assume that we've probably added integers before sometime in our past, so I'm going to go through this part a little bit quicker, but still teach you a little bit there. So just recall here real quick, integers are the numbers like -3, -2, -1, 0, 1, 2, 3. Those go on forever in both directions, but they're whole numbers. They don't have fractions or decimals. So just our rules to remember: if you're adding integers with the same sign or with different signs, follow this process here. If they have the same sign, you're going to add the numbers and then keep the same sign. So here's the idea here, is if you have 3 plus 4, you're going to add 3 plus 4 and get 7. And you keep the sign of those. Both of those were positive, so I'm going to keep that as a positive 7. Whereas if I had -3 plus a -4, notice again they're both at the same sign because they're both negative. I'm going to say 3 plus 4, which comes out to be 7. But I'm going to keep their sign, which is negative. Those are both negative numbers, so I'm going to say -7. And you could visually see that on a number line here. 3 plus 4 more is 7. -3, which is from 0 to -3, plus a -4 more takes you out there to -7. But if they have different signs, we're going to subtract the numbers. Normally we do the smaller from the bigger one. And then we keep the sign of the bigger number. I use bigger in quotations because technically, like over here, this 2 is bigger than the -5, but I say bigger in the sense of just looking at the absolute value of those numbers. So like I consider 5 to be a bigger number than 2. So for this here, I'm going to say 5 minus 2. 5 minus 2 gives me 3. The bigger number in this case is the 5, so my answer is just going to be a positive 3 because that 5 is positive. Whereas in this example here on the right, I'm going to say 5 minus 2, which gives me 3. But since my 5 is negative, I'm going to say -3. Okay, so to kind of illustrate this, I'm going to start at 0 and go out to 5. I'm going to go back 2, and then I end up at 3. This one, I'm going from 0 to -5, and then I'm going back 2. So this puts me there at that -3. Alright, so let's just try this rule a little bit here. These have the same sign, right? -10 plus a -3, so I'm just going to say 10 plus 3, that's 13. These are both negative here, so I'm going to keep the sign of that. So it's going to be -13. Part B is going to be -10 plus 3. Different sign, so I'm going to say 10 minus 3, which gives me 7. The bigger number, 10's bigger, is negative, so it's going to be -7. 10 plus a -3. Again, they have different signs, a positive 10 and a -3, so I'm going to say 10 minus 3, that gives me 7. The bigger number there is positive, so my answer is just going to be 7. And then -3 plus 10, again, different signs, so I'm going to say 10 minus 3. It's going to give me 7. The bigger number is the 10, so I'm going to keep the positive 7. Okay, so enough of that. Moving on. Let's talk about terms so we can learn how to combine like terms. Terms has an integer, maybe negative or positive, and maybe one or more variables or letters. And terms are separated by plus or minus signs. Then numerical coefficients, the coefficient is the number part of a term. The number part of a term. Also, we most of the time just call them coefficients versus numerical coefficients because we don't like to say huge words like that. Alright, so our instructions for this part is to tell the number of terms and then list their coefficients. So let's just notice real quick here that we have 1, 2, 3 different plus or minus signs, which means I'm going to have, because let's kind of just like separate it, like cut it into, notice, 4 different parts. So I have one term here, another term there, another term here, and another term here. So I have 4 terms. terms. So now let's just list the coefficients. So we're looking at the number part of this first one. The number part of this first one is a 4. So the first coefficient there is 4. Then of this, we see a 3. So we initially just want to say 3, but there's actually a negative 3. It's a negative 3. Here I don't see a number, so I want to say there's none. But if there's no number written there, then we know that it is a 1, because there's just one z. And same idea here for this one, except for this is a negative 1, because it's a negative sign in front of it there. Alright, for part B, again, notice I have two signs, a positive and a negative here. So that means I have 1, 2, 3 terms. I'm going to write that, 3 terms. And then the coefficients of this first one, there's no number written there, so it's going to be a 1. Coefficient of the next one there is a 17. Coefficient of that third one there is a negative 4. So this is going to be my answer for that one. Alright, like terms are terms that have identical variable parts including exponents. And those variables may appear in any order. May appear in any order. So let's look up here at part A. It says simplify if possible. So notice here I'm seeing this one here has an x and this one has an x. And then this one and this one don't have any variables. So those match. And to simplify, we combine those like terms. So think about if I have 5 x's plus 1 more x, right, because the coefficient on that one is 1. 5 plus 1 is 6, so I'm going to have 6 x's. 6 x's, and then I have a 3 minus 1 is going to give me 2. So plus 2. These two I cannot combine together because this one has an x and this one does not have an x. So the variable part does not match, so I cannot combine those together. So this is as simplified down as I get. 6x plus 2. I'm moving on to this next one here. I notice that this one has an x and this one has an x. However, this one has an x squared. This one just has an x and this one doesn't have any x's. So can I combine these two together? The answer is no, because the variable part does not match exactly. They're close, but they don't match exactly. I guess the other question is, can I combine this one and this one because I see a 4 in each of them? Well, no, because the variable part has to match exactly. This one has an x, and this one doesn't have any. So that this one, in fact, does not simplify. Alright, now we're going on to part C. I'm seeing a Q here, and a Q here. I'm seeing an R here, and an R here. And I'm seeing constants here, 2 and 2. So let's combine the red ones. Q minus Q, so 1Q minus 1Q is 0 Q's. So if we want to write that, we can say 0 Q's. R plus R, 1R plus 1R is going to give me 2 R's. And then negative 2 plus 2 is going to give me 0, so plus 0. But notice, if I have 0 Q's, do I really need to write that? And then if I have plus 0, do I need to write that? Not really. So I'm just going to write my answer as 2R. Okay, so you need to simplify down those zeros and get them out of there. Alright. Part D says, find the perimeter of this shape. And since this is a rectangle, since this side is 2x, I'm going to know this side is 2x. Since the top is 10, I'm going to know the bottom is 10. And to find the perimeter, I just have to add up all the sides. So to find the perimeter, I'm going to say 2x plus 10 plus 2x plus 10. And then of course we're going to simplify that down as much as we can. So 2x's plus 2x's is going to give me 4x's. 10 plus 10 is going to give me 20. And I cannot combine those together because my first term there has an x and my second term does not. So then my perimeter is going to be 4x plus 20. Your homework is there on page 207. You're going to do the practice set, all of them from lesson 31, all of them from lesson 30, and then a whopping one more of your choice. Good luck.